In Episode 5, titled The Data Science Lifecycle at Exam Level From Problem to Production, we are going to map lifecycle stages to what the DataX exam rewards and to the kinds of decisions professionals actually make when data becomes something the business depends on. The phrase data science lifecycle can sound broad, but on an exam, it becomes very specific because each stage creates different risks, different constraints, and different best next step choices. The purpose here is not to teach you an idealized diagram, but to give you a mental model you can apply quickly when the exam drops you into a scenario and asks what to do first, what to do next, or what choice best satisfies the goal. You will notice that many wrong answers sound like later stages when the prompt is actually testing an earlier stage, and this life cycle framing makes those errors easier to spot. By the end, you should be able to hear a prompt and immediately place it on the life cycle timeline, which is a major advantage under timed pressure. Before we continue, a quick note. This audio course is a companion to the DataX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. The life cycle starts with problem framing, and at exam level, that usually means identifying stakeholders, success criteria, and constraints before you touch methods or tools. Stakeholders are the people who will act on the result, fund the effort, or carry the operational risk, and the scenario often hints at them through job roles and decision responsibilities. Success criteria are the outcomes that define whether the effort worked, and they must be tied to a real decision rather than to a vague desire for better insights. Constraints are the boundaries you cannot ignore, such as privacy obligations, deadlines, limited compute, approved platforms, or licensing restrictions on data sources. On the exam, the best answer in this stage often focuses on clarifying what success means and what limits apply, because those choices determine everything that follows. If you have ever seen a project fail because nobody agreed on what good looked like, you already understand why the exam treats framing as a professional competency, not a soft skill. Once the framing is clear, you translate the goal into measurable outcomes and select appropriate metrics early, because measurement is how you keep the project honest. A measurable outcome should reflect the decision that stakeholders care about, such as reducing false alarms, improving throughput, detecting rare events, or increasing reliability of forecasts. Metrics should match the outcome and match the data reality, which means you need to consider imbalance, error costs, and whether aggregated performance hides important failures. Selecting metrics early also prevents the common trap of optimizing what is easy to measure instead of what matters, which can produce impressive numbers that do not improve the real-world result. In exam questions, this shows up when the scenario's objective is specific, but the answer options offer metrics that are popular rather than aligned. When you develop the habit of aligning outcome to metric early, you make it harder for distractors to pull you toward technically correct but contextually wrong choices. Data acquisition planning comes next, and at exam level, it is not just about where data exists, but about what you are allowed to use and what risks come with it. Sources might include internal systems, third-party providers, public datasets, or sensor and event streams, and the prompt may mention availability, coverage, or quality concerns. Licensing limits matter because they can restrict redistribution, derivative use, retention, or even the ability to combine a source with other data, which can change what is feasible. Privacy needs matter because they influence what data fields are acceptable, how access is controlled, and whether data must be minimized, masked, or handled under specific policies. On the exam, a common pattern is that the best technical data is not the best allowable data, and the correct answer respects that boundary. If you treat data acquisition as governance plus practicality, you will choose answers that are defensible rather than merely ambitious. After acquisition planning, ingestion and storage design become the next decision cluster, where you balance formats and refresh cadence against constraints and use cases. Format choices affect how easily data can be validated, transformed, and queried, and the scenario may hint at structured records, semi-structured logs, or unstructured content. Refresh cadence is about how often data must be updated to support the decision, and this is where streaming versus batch implications quietly appear even when the question does not use those words. Storage choices also relate to retention, cost, and access patterns, because keeping everything forever may be technically possible but operationally irresponsible under privacy and budget constraints. In exam language, you will often see hints about timeliness, reporting windows, and operational latency, and those hints exist to shape your ingestion and storage reasoning. The best answer is the one that fits the decision rhythm of the business while respecting the boundaries the prompt described, not the one that maximizes technical capability without purpose. Wrangling is where the life cycle becomes tangible, and at exam level, you need to be able to run wrangling steps mentally, especially join keys, deduplication, and field standardization. Joined keys matter because the wrong key can create silent duplication, loss of records, or mismatched entities, and those errors often show up later as mysterious performance problems. Duplication is not a generic step you always apply, because duplicates might represent legitimate repeated events, and the correct choice depends on what the data represents in the scenario. Standardizing fields, such as date formats, categorical labels, and units, is a reliability move that reduces downstream confusion and makes comparisons meaningful. In many DataX questions, the prompt hints at inconsistencies or pipeline issues, and the correct next step is to stabilize the data before attempting analysis. When you can narrate wrangling as a sequence of integrity checks, you are operating at the level the exam wants, where you prevent preventable errors rather than reacting to them later. Exploratory data analysis, often shortened as EDA once you have said exploratory data analysis the first time, is another stage that shows up on the exam as reasoning rather than as charts. The exam will not ask you to draw a histogram, but it will expect you to recognize why you would inspect distributions, relationships, and anomalies before making confident modeling decisions. Distribution reasoning helps you notice skew, outliers, missingness patterns, and category dominance that can break naive assumptions. Relationship reasoning helps you identify correlated variables, potential proxies for sensitive attributes, and signals that might be leakage if they are too close to the outcome. Suspicious anomalies are often the story the data is telling you about collection errors, pipeline drift, or business process changes, and ignoring them leads to fragile results. In exam scenarios, the best choice is frequently the one that validates the data story before optimizing models, because early detection of anomalies prevents expensive mistakes downstream. Feature engineering comes next, and it is tested less as a bag of tricks and more as thoughtful handling of categories and numeric variables in a safe, defensible way. Encoding categories is about turning labels into representations that a method can use, but you must avoid creating unintended ordering or exploding complexity beyond what the constraints allow. Scaling numeric variables is about ensuring that magnitudes do not distort learning, but it must be done in a way that respects partition boundaries so you do not leak information from evaluation into training. The exam often rewards caution here because feature engineering can introduce subtle errors that inflate performance temporarily and collapse in production. If the prompt hints at mixed data types, high cardinality categories, or a need for interpretability, those are signals that should influence your feature decisions. A strong exam mindset is to engineer features in a way that improves signal while preserving governance and evaluation integrity, rather than chasing clever transformations that are hard to justify. Modeling begins with baseline choices, and the exam frequently rewards baseline-first discipline because baselines are how you establish whether you are solving the right problem. A baseline model provides a reference point and helps you detect if the data pipeline and metric selection are coherent, because if a baseline performs strangely, something may be wrong upstream. Comparing improved approaches objectively later requires that you keep evaluation consistent and avoid tuning to the evaluation set, which is a common trap in both learning and real projects. The exam tends to include distractors that jump straight to complex methods, because complexity sounds impressive, but the best next step is often to establish a baseline and then iterate. When you see answer options that suggest advanced modeling without any mention of baseline or validation, you should be suspicious unless the prompt clearly places you later in the life cycle. The goal is not to avoid complex models, but to earn complexity through disciplined progression. Validation is where exam-level mistakes are easiest to spot because the test writers know that leakage and sloppy evaluation are common failure modes. Splitting data correctly is foundational, and you must respect time-based splits when the scenario implies temporal order, because random splits can leak future information into training. Preventing leakage also includes avoiding feature preparation steps that use global statistics computed across all data, because that can leak evaluation information into training and inflate performance. Documenting assumptions is part of validation in an exam sense because it shows professional awareness of what was unknown, what was inferred, and what might break if conditions change. In many scenarios, the best answer is the one that protects the integrity of evaluation, even if it slows you down, because a fast wrong conclusion is worse than a slow correct one. If you treat validation as a risk control, you will consistently choose answers that the exam rewards. Deployment thinking appears more often on modern exams because data products are expected to live in production, not just in notebooks. Inference needs are the practical reality of how predictions or outputs will be used, whether in real-time, near real-time, or in scheduled cycles. Monitoring matters because production data changes, upstream systems change, and a model that performed well in training can degrade quietly if nobody is watching. Rollback readiness is the operational safety net, because when something fails, you need a plan that restores service without turning the situation into a crisis. The exam is not looking for vendor-specific deployment steps, but it is looking for evidence that you understand production as a controlled environment with risk management built in. When a prompt hints at operational impact, user-facing decisions, or regulatory obligations, deployment thinking becomes part of the correct answer, even if the question seems to be about analysis. Communication is a life cycle stage that many technical learners underestimate, but the exam treats it as core because decisions happen through communication. Clear communication includes stating results in business terms, connecting metrics to the objective, and explaining what the result means for action. Highlighting limitations is not weakness. It is professional honesty that prevents stakeholders from over-trusting a model, misusing a dashboard, or making decisions beyond what the data supports. Aligning to business value means showing how the outcome improves a real process, reduces risk, or increases confidence, rather than presenting the technical achievement without context. In exam questions, The best communication-oriented answers often emphasize clarity, transparency, and decision relevance, while distractors emphasize technical depth without explaining impact. If you can keep the life cycle in mind, you will notice that some questions are really asking, how do you communicate responsibly, even when they mention metrics or models? The life cycle closes the loop when you track drift, define retraining triggers, and incorporate stakeholder feedback, because production systems exist in changing environments. Drift can be data drift, where inputs change, or concept drift, where relationships between inputs and outcomes change, and the exam often signals this through declining performance or changing conditions. Retraining triggers should be based on monitored signals tied to the objective, not on arbitrary schedules, because retraining too often can create instability, while retraining too rarely can let performance decay. Stakeholder feedback matters because it reveals whether outputs are usable, whether unintended consequences exist, and whether the model is influencing behavior in ways that change the underlying data. The exam rewards the mindset that treats deployed analysis as a living system with governance, monitoring, and iterative improvement. When you understand that loop, you will choose answers that focus on sustained reliability rather than one-time performance. To conclude Episode 5, it is useful to be able to recite the life cycle stages in your own words and then apply them to one scenario, because that demonstrates that the life cycle is a tool rather than a diagram. The sequence you choose should reflect the idea of moving from framing to measurement to acquisition and preparation to analysis and validation, to production and communication, and then back to monitoring and improvement. When you apply the stages to a scenario, you are practicing the exam skill of placing a prompt on the timeline and selecting the best next step for that stage. This also strengthens your ability to reject distractors that belong to later stages because you can recognize when an option is premature. Keep the practice simple by choosing a realistic workplace decision and walking it through the stages, focusing on goal, data, reality, and constraints at each point. If you can do that smoothly, you are building the exact kind of structured judgment DataX is designed to reward. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.